So when we're looking at where we're at, we had a 20-page assignment last week, 20 pages, most of which, or a lot of which were lab setups. They were just for reading. You had 12 pages that are due. They were due on Friday, but we extended it to today. It's okay if you want to turn them in late, but we're running out of time. On October 19th, this is the 7th, it's October 7th. Well, I'm writing it all down. I forgot that it's not screen sharing. Check. And we have 12 pages due. Today, it's okay if you turn late, but it's October 5th, and the 19th is the due date, and is the day for your grades.
Wait, October 19th is the last day?
October 19th is the last day for grades. So I have to stop everything and make sure all the grades are accurate before October 19th. I'm not playing around with 132 grades and making somebody's grade bigger, better, or worse than it really is. So October 19th is not the deadline for you, right? Because October 19th is when the grade book closes, right? Actually, it is. Let's just make it October 19th because grades are due right after that. So that weekend, I will finalize grades. So October 19th is your deadline. So whatever you're going to do with yourselves about your assignments, if you haven't done anything last week, that's really sad that you didn't get anything done. Now, I understand some of you were saying you looked at the work and you were completely confused. I have questions about that. I have concerns about that, but let's move on. Could I have someone's copy of the work? Could someone tell me any of the answers or questions that you might have come up across that really confused you? Please feel free to open up the work online and ask your questions from the document directly. Huh? From Monday. It was an assignment that was given to you on Monday that was 20 pages long. That about half of it was labs. And about 12 pages, you had to work through some basic chemistry assignments, like what is an atom, can you draw an atom, that kind of stuff. By the way, a lot of it was in your notes. A lot of the answers were in your notes, which is what's concerning about not being able to get it done. But could someone walk me through this? The first question they ask you on it? The silence is telling.
Like the first page?
First page, first question. What is it?
A quantum model of the atom is a drawing that represents the nucleus and the electron cloud. Draw the quantum model of the atom using the nucleus.
So I did this the first day we talked about atoms. I labeled it, and I told you that normally people, when you see an atom, what a lot of people will draw is something that looks like this. Correct? What we said on that first day was that really, if you really wanted to draw an atom, you would draw something look more like this. And this is what's called the quantum model. And the reason we call it a quantum model is because this is an electron cloud. There's a term in chemistry, this idea of quantum, and you've heard of quantum numerous times on the news if you pay attention to your environment. In fact, we have quantum computers coming out soon, I hope. There's a lot of quantum mechanics being used for security of passwords, etc. So your whole generation is moving in this direction. is using the rules of physics that apply to this very tiny, this quantum world. And I think you've seen that on the Marvel movies, in the Marvel movies with Ant-Man. Have you seen that, the Marvel movie with Ant-Man, where he goes real tiny and goes into the quantum realm? All right? That quantum realm is, it's all about unknown, unpredictability. The rules are different than they are for us here. Our rules are relatively simple. You can only be, for instance, you can only be one place at a time. Particles in the quantum world can be in more than one place at the same time. We just measured light interacting with an electron before it actually happened. So they travel through time. They experience negative time. These are things that we don't understand, correct? Do you understand negative time? Do you understand it? Because I don't. Positive time is, how long? 1 1,000, 2 1,000, 3 1,000. You add, right? Imagine being able to move backwards in time. You're going forward. You're getting older. Imagine actually going younger, going back in time. Well, in the quantum world, that happens all the time. Or at least, and it's been measured that it occurs. So the rules are different in the quantum world. And we call it this unpredictability. So instead of drawing it this way, the way we would draw it if electrons were planets, we draw this kind of cloud, and that's the quantum model. Now the other thing you could have drawn is you could have put protons in the center, and you could have put a shell that represents a predictability, right? A probability circle. So you could have put your little electrons here, and then draw another sphere, and then put another electron here, and that could have been your 1s, and this is your 2s, and you could have said something like, there would be, I don't remember how many neutrons lithium. This is the atom called lithium. You can look on the somebody tell me the mass of lithium on your periodic table. I know it's atomic number 3. Lithium, Li, atomic number 3. Is how many, what's the mass? 6.9? So 7. So 1, 2, 3, 4. So that, something like that would be lithium. That's also a quantum model because these shells are quantum shells. So really, this is the cloud that they wanted you to draw. But you could have drawn something like this that has all the different, these different shells. But nothing, if you drew this, that's wrong, right? Because that's what before we understood some of these rules of the tiny, we drew the atom like this. A real useful rule of, do you want to know a useful rule for the quantum world that we can use for computers, that we're using for computers? In fact, at Cleveland Clinic right up the street, they're building a whole new building just for a quantum computer. Do you want to know what the rule is? Right now with these computers that you have in front of you, you have 2 choices, on or off. On or off, yes or no. Does that make sense? It makes perfect sense. And the computer works, and you can program it very easily because it's either yes or no. And you can make a flow chart of decision making. And when you're in Mr. Krishnan's class and you're making a program, it's real simple, on or off, yes or no. In the quantum world, you can have yes, you can have no, but you could also have maybe. Or another way of saying is yes and no. because particles can be more than one thing at a time. So now you have something that's more like our brains work, because our brains are not just yes or no. Our brains are yes, no, and maybe. Well, they have quantum computers can do yes, no, and maybe. So they can do trillions of calculations much, much faster than these computers that we have in front of us. So imagine being able to program a quantum computer with AI that now, as powerful as AI is now, imagine a quantum computer that's working on AI. Now you got a real powerful machine that could really help you solve problems that were unsolvable before. So that's the answer to the simple answer is this drawing right here. All right, what's the next question? And by the way, this was in your notes. What's the next question?
What do you notice about the relative mass of the proton and neutron? What about the electron?
So again, I gave you this answer, didn't I? This is an answer. It was given to you in your notes. A proton mass, the mass of a proton equals the mass of a neutron. An electron's mass is negligible. Right? We said that. It says tiny. Again, answer given to you, number. So that's two of the big questions were already answered before you got this done. So when people tell me they're staring at the page and not knowing what's going on, it kind of tells me you're not listening in class either. All right, what's the next question? Yeah. Here? Yeah. What is, I want to emphasize for people that just came in, the deadline for all late work is the 19th. I'll post it like I always do, and you'll get a syllabus for the next few weeks soon, and you'll be fine. You have time, but I just want everybody to be clear before I even send the first message home. The 19th is the last day I can deal with that with late work, okay? All right. What, is it a bug, dude? Just tell, where is it? Why does a bug disrupt class more than anything in the world? Where is the bug?
Where's the bug?
Oh my Lord Jesus. All right, let's move on. So, electrons and mass are negligible. What's the next question?
Is the mass of an electron taken into account for the atomic mass? Why or why not?
And this answers it, right? The electron's mass is not taken into account in the atom's mass because the electron's mass is negligible. It is really, really small. And I think I used the example, if this man who's standing in front of you, 270 pounds, is getting on a scale and a little slip of paper gets put on his head, is that going to change the scale? No. So we can ignore it because it's so small. All right. All right, what's next? Next? Question? Atomic mass units? That's another one that we answered in class. Remember, we said one proton is equal to 1 AMU. That's atomic mass unit. Atomic mass unit. And also because a neutron's equal to that, every proton, every neutron equals 1. So if you have, well, let's look at what I did with lithium. If I have an atomic number of 3, so I know I have 3 protons, and she told me I had about 7, a mass of 7, I rounded up, a mass of, because it's an average, remember I said that, mass is an average, so I rounded up, so that's 7, I know I had 3 protons, I knew then, by my deductive reasoning allowed me to say I have 4 neutrons. If you want it spelled out, I'm going to say it again just because you're going to need to do it on the test. You probably won't have to do it on the OST, but I think it's important enough that we should think about it, especially when we start to talk about radiation and centrifuging and etc. When you take a look at it, if you have atomic mass of 7, that's 7 AMUs, and 3 of those AMUs are protons, then 4 have to be neutrons because they can only be protons or neutrons. We don't have to worry about electrons. So there you go. All right, what's next? Next question.
What can knowing the number of protons allow you to do?
I just did it, didn't I? Allowing you the number of protons allows you to figure out the number of neutrons and the number of electrons if the atom is neutral. So knowing the number of protons do you all agree that this is stuff that we covered? Yes?
Yeah.
Yeah. It's in the notes. I'm not making this up. You can go back and look. But knowing the number of protons, if I give you the notes and I tell you they're important, and then I give you a worksheet that goes over that stuff and you have a week to do it, you should be connecting the dots. It's okay that you didn't. I'm not judging anyone. Please understand that. But just learn from your experience. Start going over your notes. It's not a joke. I'm not telling you stuff you don't need. All right. Knowing the number of protons, tells you if you know the mass. Let me set it up a different way. Knowing the number of protons, if you know the mass, let me rewrite that because it's a little messy. You guys hate it when it's messy. It's hard for you to read. I don't blame you. So knowing the number of protons, if you know the mass number, the atomic mass, then you know the neutron number. Does that make sense? If I tell you the proton number, if you know the proton number and you know the mass number, then you know the neutron number. Does that make sense to you? Please say yes or no. All right. If, on the other hand, if you know the atom is neutral, yeah. Let me rephrase that. Huh? Yeah. If you know the atom's charge, then you know how many electrons. So if you know the number of protons and you know the charge, then you know how many electrons you have. So an example calculation in each of these would be something like if I know the mass number of 7, AMU equals mass, and I know there's 3 protons, let me just put atomic number, then that's going to equal 4 neutrons. As I've done, as example after example, as you've done in class. If I know that there's 3 protons, and I know there's a +1 charge, then I know what? If there's a +1 charge in total, then I know I have 2 electrons. How did I figure that out? If I have 3 plus 3 minus what? Equals +1. That's a 2. You see, you're using your algebra and your middle school math. You're using it. You're going to use it the rest of your life. It's just you don't know when you're going to use it. So you need to learn everything you can. You just don't know when you're going to use it. The mathematical reasoning, the mathematical thinking makes your life easier in ways you cannot predict. Please don't assume just because you're not going to be a mathematician, engineer, or even a scientist that you won't use these skills. You do not want to have to stare at a piece of paper for a week with your friend because you don't want to learn that mathematical reasoning. So there it is. That's how you get the +1. And also, I hope it's obvious at this point. Another thing that you know, if you know the number of protons, and if you know the number of neutrons, if you're given the number of protons and the number of neutrons, then you know what? The atomic mass. All right? So there's 3 big things you know. 1, 2, 3. Or you can figure out if you know the number of protons. Does that make sense to everybody? Does anybody have an issue with that answer? All right, and I think we covered everything in there. You've taken a week before you had this week-long assignment project. We covered everything in your notes. All right, what's the next question? What's the next question? Okay, that was an easy one. An unknown element has, and it's not really unknown if you know the atomic number because you have a periodic table. By the way, the guy that came up with a periodic table was this Russian guy named Mendeleev. Very interesting story behind it. Really cool example, somebody figuring it out. Somebody just like you sitting there. By the way, look at me when I'm talking to you. Looking at a piece of paper. Literally looking at paper for days, for months. He decided to put them all on cards and just try to find a pattern. He worked on it for months, and he came out with the first periodic table. It's just like you. Stared at, except he didn't give up. He just stared at and stared at and stared. He kept working on it, asking people, came back to it, and figured it out. So don't give up if something's confusing. Understand, it's confusing to everybody the first time. Okay? So what was the atomic number? Unknown element With atomic number of what?
8.
So what is the element? What element has atomic number 8? Oxygen. All right? How do we know that? Did we memorize it? Heck no. There's a periodic table. You look on the periodic table. Let me pull it up. We will be building atoms, don't worry. We're running out of, I'm really kind of pushing it with the time scale. Hopefully we get, did I miss it? Oh, there it is, thank you. Periodic table, and you can see that the atomic number 8, you can't, it's hard to see here because it's a little blurry, but 8 is right there. 8 is oxygen. O for oxygen. It tells you everything. It tells you how many protons with the mass number. It tells you the group it's in, the period it's in. Everything you want to know is right there on that periodic table. It's a great tool. I'm going to find a good one and print it in color for you. I was going to do it the weekend I was sick. I did not get a chance, but it will happen. Okay? And laminate it. All right. What else? What do we got? Oh, we already did that, yeah? So we answered that question already. Great. Yeah, there's another one. Go ahead. We just did that. Knowing the number of protons allows you to do this. These 3 things. It allows you to figure out the number of neutrons, right? You can figure out how many electrons you have. This is how you do it. You have to know the charge. Just because you know the atomic number, that doesn't mean that the atom is neutral. It wants to be neutral. It will move towards being neutral. It'll have chemical reactions until it's neutral. Period. But it doesn't mean it is neutral that second that you're looking at it. So somebody has to tell you that it's neutral. There has to be some kind of implication that it's neutral for you to figure this out. Or tell you the charge. Like I say here, if they tell you something has 3 protons, lithium, which has 3 protons, has a +1 charge, that means it has 2 electrons. How do I know that? Because +3, protons are positively charged, +3 minus 2 equals 1. The -2 is the electron number. All right. And of course, if you know the neutrons and the protons, you know the atomic mass. Are we all good with that? All right, let's go on to the next problem. What's next? What is what? Here, let me just, can I keep it here? You sit next to me? You can take notes. And close the door, will you? And they say defining elements and compounds. They say Fe is the elemental form of iron. All right, so they say Fe. That's how iron is that's the symbol for iron. It's the element iron. C is for carbon. Cl2 is chlorine, is the elemental form of chlorine. So when we find iron, and pure iron is just iron by itself. Carbon is just C by itself. Chlorine is found in Cl2. It's a compound. It's a molecule, and we have FeCl3. FeCl3 is a compound formed from the elements iron and chlorine. This is a compound. Compound means more than one thing. A compound sentence is what? More than 2 sentences put together. That's a compound sentence. 2 or more put together. Is that clear, ladies? I don't want you confused. in the future. Compound means more than one thing put together. Element means pure. This is an element, this is an element, and this is an elemental form because there's nothing else in it. Elemental form. Again, so, an idea we covered. We did not cover compounds. So if you were confused about compounds, good. You should have been. What does the subscript in Cl2 mean? What does that little 2 mean? 2 atoms of chlorine. Excellent. That's the answer. 2 atoms of chlorine. And by the way, Cl2 means 2 atoms of chlorine that are bonded to each other. They are chemically bonded to each other. Now, if we look at the periodic table really quickly, you see chlorine only needs 1 electron. Chlorine needs 1 electron. They need to make only 1 bond. How do I know that when I just looked at it just quickly like that? How do I know that? I told you to look at what when you're looking at the periodic table? Look at the group number. This tells you how many electrons are in the outer shell. And it wants 8. It has 7. So how many does it need? 1. This has 6. These have 6. And they want 8. How many do they need?
2.
So all these make 2 bonds. These make 3 bonds. These make 4 bonds. That's why carbon makes 4 bonds. And these make 3 bonds. 5. These are weird. We're not going to get into these. They're called metalloids. So we're not going to talk about any of these because they're a little bit stranger as well. Except maybe like iron. Once in a while we'll talk about iron or something like that. But so they have more than one possible charge, because we call them transition metals because they're in transition. 2 atoms of chlorine. So Cl2 looks like this. 1 single bond. Why? I'm going to draw the Lewis dot structure that I taught you already. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Remembering that they want to share 1 bond. Why are they sharing that 1 bond? So they can both have 8. Boom. Done. Okay? Now that part I covered, but we didn't cover the word compound. So Cl2 looks like that. All right. What is implied when there's no subscript? If I just put C by itself, what does that mean?
There's only 1 atom?
There's only 1. If you don't put the number 1, we just assume it's 1. If you have the symbol, we assume it's 1. Just like algebra, right? And algebra can be a bummer sometimes. It shows up in places you wouldn't expect. All right. Next, evaluate the statement. The formulas for elements never contain a subscript. Is that is that statement true? They never contain a subscript. That is correct. Why? Because an element is pure. Or is it? Look at this. Is it true or not? No. The evidence is right in front of you. The answer is no. And why not? Because sometimes they bond to each other. No. Sometimes elements bond to each other and make molecules. All right? and we define molecules. That's a molecule when elements or when atoms bond to each other, they're molecules. But sometimes, like chlorine, it's the two of the same. Another example is oxygen. Oxygen forms a double bond because it's in the group. It's in group 6. Another example might be CO2 is not an elemental form, but chlorine gas, oxygen gas. These are two of the atoms bonded together of the same element. Are we clear on this? Can we move on? Okay. What's the next question? Help me out. I don't know. I lost my spot. Thank you. From the two examples provided, would you expect the formulas S8 to represent a compound? A compound? I believe they meant to write or an element. S8 is an element. It's an elemental form. Bless you. S8, if it's a real thing, it's 8 sulfurs bonded together. That's it. Correct? It's a pure form, so it's elemental form. It's just a molecule. There's 8 of them, all bonded together. All right? I've never seen it, so I don't know what that's all about. So I don't even know if it's a real thing. I can't tell you. Are we all good with that? All right. Now let's do some exercises using that information. Classify each formula below as being an element or a compound. All right? CO. If you look at the periodic table, you'll find CO is what? Start elemental table. CO is cobalt. It is an element. And I'm just going to make a chart, compound. CaCl2. Is that more than one thing? Yes, so it's a compound. SiO2, compound. Why? Because it's more than one thing. PF5. Bless you. More than one thing. Compound. P4. Phosphorus. These have calcium and chloride. This is silicon and oxide. This is phosphorus fluoride. So there's more than one thing in the compound. CSOH, 3 things. Notice that when it's one thing, that's cesium, there's a little lowercase letter. That when it's 2, these are 3 elements because every capital letter is an element. So Cs is one element, oxygen is another, hydrogen is the other. So it's cesium hydroxide. This is bromium. Br2 is bromium. And what do we got? OF, oxygen, I don't know what they'd call it, but oxygen fluoride, sodium bromide. And here's something, C6H12O6. That's sugar. That's carbon, hydrogen, and oxygen. That's C6H12O6. That is something we will be building this week. That is sugar. But there's only 3 elements there. All the rest are compounds. Simple, yes?
Yep.
Are we good? We'll finish this tomorrow? What? CaCl2. It's right there in your, all these are written from your document. All right? So they're just organizing what's in your document.
You said 12 pages is due today.
It's due today, but you can turn in for no penalty before what date?
The 19th.
The 19th, okay. So I'm going to finish it tomorrow. So be ready to finish the answers tomorrow. There's no excuse. I'm giving you the answers. while we're waiting for somebody to look up the question, I'm going to correct the date here. I think I put the date as October 5th. It's actually October 7th today, isn't it? So I'm going to erase this and put the 7th. Does somebody have the next question? What is the next question, guys?
What clues are given?
So go ahead. Anybody?
What clues are given in chemical formulas that allow you to differentiate between an element and a compound?
The clues are really not. It's more of a slap in the face than a clue, right? The symbols. If you have different symbols, then it's a compound. If you have the same symbol over in that, whether it's multiple subscripts or single, it doesn't matter. If it's only one symbol, then it is an elemental form. Are we good with that?
Yes.
It's not really a clue. It's kind of a statement. All right. What's the next thing? Next question. What's the next question? One more question. Let's answer it. One more question. This was an oddly phrased question. It was really weird when I looked at it. So more than one kid came up. So what they mean, they don't mean the group 1 on the periodic table, which is what I thought at first and what a lot of people thought. But what they mean is there's two groups. There's a table on the right and a table on the left. I mean, a column on the right and a column on the left. Do you see that? The one on the left is group 1. The one on the right is group 2. If I were them, I would have called it something else, because the periodic table has groups and it's just very confusing. We all understand that? And we'll finish this tomorrow. All right? If you want to turn in, you can, but we'll have all the answers done tomorrow. I think you see, I hope I made my point that this was all covered in class.